And then I think we can start to get going. Rock on. Let me share now my slides. Hopefully you're all seeing slides now. Let me know. It's like, yes, yes.
Yeah, slides look great.
Slides look great. Rock on, rock on. All right, everybody. Hopefully you're ready. I'm ready. Get a little bit more tea. We'll be good to go. So, introduction to Web3 technologies. Of course, we're doing the build a blockchain startup, centralized applications, and this is going to be so much fun, you guys. This is kind of the fundamental things that go into what Web3 is, I think, and we'll really be able to dive deep into some of these topics, but more so today, it's about being broad, and we're getting a big picture of a lot of how this works, so that everyone can come to a common understanding of what the technology can do. So while reading, please do take of your note or note of your thoughts while reading, watching here, I suppose. What questions come up for you? What terms do you not recognize? Because there's probably going to be a lot of them. What like content is confusing or potentially missing, especially those in that poll who are answering that, like, this stuff pretty well. I probably am missing some stuff because I know I learn new things every day. So please let us know in the chat on AirMeet specifically. And feel free again to answer if you know the answer for your peers, please do. All right, so let's kick it off. Before there was Web3, which we're talking about today, there are many enabling technologies and systems collectively that power blockchains and Web3 in general. So let's review a few of these. Right. So this might be basic for all the comp sci people, but really, what is a network? Right. Well, this, at least as I'm defining it here in the context of this class, is a group of anything that share links to each other, really. And in a computer network, this connects a set of electronics that are wired, or wirelessly connected to each other. Some kind of communication is implied across this network. Right. So terminology that we're going to be using today across the network is we have nodes. This is one unit, right? Or you could think of peer, or you could think of this as one particular device, right? And then a link is one that connects between these two. A server then will go into the context more there, but typically this is a node that links with many, many other nodes. And a client is typically one that links with one server specifically. And that's really the only relationship that it has with it. So you can think of most, like, for instance, right now you're watching through your browser client a server that AirMeet is hosting for us, right? As an example. So what is the internet, right? It's kind of an abstract thought, but really, like, if you get down to the Wikipedia definition, right, it's a massive network of networks, right? It connects millions of devices, maybe at this point billions. With IoT, who knows, trillions. But it also defines a standard for communication across all these devices. Specifically, HTTP is kind of the thing everybody's using across the internet today. And more fundamental to that, you get like UDP and TCP and ways to actually like communicate between devices. We don't have to get into the details here, but understanding that there are protocols and standards amongst how you talk to each other to be able to have this network be doing something functional, especially when we're talking to different networks than our own. So here's kind of a snapshot to all get us on the same page that internet users here have like there's really high access, especially in the developed, first world, but it's not everywhere, you guys. Like I think that we kind of take for granted that everyone has a smartphone that's connected to 5G and we can blaze whatever we want at infinite speed. But for much of the world, even basic access to the internet at all actually is not a guaranteed. And even in the US, we'll have rural places that are not. So preview for next time, we're going to talk a little bit about offline first technologies as well. But online, really, the point of the internet is you can connect to basically any device that exists in the world now, which is pretty crazy, right? And information can spread almost instantly across the globe. And really, though, often whenever we're making these connections, we connect to a few large, secure, and trusted central servers, right? Like for us today, it's AirMeet and like Google Slides, for instance, right? So this is a really old graph at this point, but you can look at like who's using what. I believe this is like page hits per some period of time that we're looking at. Google is number one. And what do you know? YouTube, that Google owns, is number two. Facebook and a few other of these sites, right? As we're moving down the lines, this is where we spend almost all of our time surfing on the internet. I know that if one of these services goes down, like Google, for instance, for me, man, it sucks. Like I can hardly function a lot of the time, which is maybe another preview. We'll get more into that, like why that might be a problem. So then what is a database, right? And all the comp sci guys, you can really lean into it because I'm not a comp sci major by training. I'm an engineer in physics specifically, so I might have some of this wrong. But as I see it in the context of this class, this is just a general data storage system. And typically in this context, it's accessible by many users to read and write data from. That's what makes databases useful. And really, this is typically again on a central server, right? And you can think of it like Google Sheets, for instance. Google hosts a spreadsheet that everyone can collaborate on and reference, right? It's a pretty useful tool, right? So the cloud, another one of these big terms, right? It's somebody else's computer, basically is how I define it, right? You can store data and run applications somewhere else. It's not on your machine, your client, right? You can ask Google or in Microsoft or Amazon or Cloudflare, or whatever it might be, to spin up a computer out there in the world for you to actually do things, right? And then this is really only accessible if you have access to the internet, really, in today's day and age. And then all these operations, you have a light client, like your little like Chromebook or something, can instruct a supercomputer to do various operations. Or, for instance, you can do like cloud gaming. I think is a really fun application of that. So all of that now is kind of like Web 2, right? We're talking about the web as we know it today, for sure. At least from the high level, right? From the user perspective, everything's on a central server. In the back end, there might be some more decentralized and distributed networks, but really, this is the definition we're talking about and what really is core to what Web3 is: distributed networks, right? It's a network of nodes, so these other computers out there in the world, that replace the reliance on central servers and providers and just rely on each other, right? So we have this mutual peer network that can provide all of the services that we need and spread data amongst each other and share compute and things like this. So what this generally provides is redundancy, because it's not just in one place in the universe, potentially even on just one hard disk or something like this. It's much more reliable in the sense that we can talk to other nodes if some are down. It's much more secure in some ways and not so secure in other ways, right? We'll get into. It's much more scalable in the sense that you have to have one super mega computer that has all the ability in the world to talk to everyone else in the universe. That's not really feasible. And so in a distributed network, we can architect it such that it has much higher throughput, for instance, right? Operational overhead can be a plus and a minus, right? It's not just Google's job, for instance, if we have a distributed network that's holding a spreadsheet for us, but then across the peers and how much chatter needs to happen on the network can be a lot higher. So pros and cons there. And in general, there's pros and cons to how you administrate this. As opposed to one central authority, right? Your peers now can potentially come to some kind of democratic way about making things happen. And we'll get into that a little bit more later. You might recognize some of this though, things like Tor, BitTorrent, IPFS, we're going to have a whole class on, and in general, blockchain, right? So what is a blockchain? A blockchain is a linked list database. Right? We talked about what a database is in this specific kind of database, right? Each new set of data that's added to this database, called a block, right, directly references the last one. And because we link all of these, it's a chain of blocks of data that are entering this database, so hence blockchain, right? And the interesting part, the novel part, that makes blockchains different, right, is you cannot change anything in the previous sets of data without changing everything else moving forward, right? But man, this is boring, right? This is just comp sci 101. It's just a data structure, right, and a way to implement it. So why is there so much hype? Why are we in this class talking about it? Well, the story gets a little deeper, right? Blockchain also generally implies a protocol that validates that no data has been changed or corrupted, more so than just like ensuring that we think that it's going to be okay by the way that the protocol is set up. Right. So now we also have a distributed network of peer nodes that must come to consensus, meaning that the whole network agrees that the data is as it should be, right? From block to block. And then we design the system with game theoretic incentives that ensure fair behavior. So this is the interesting part, is that we have a protocol that leans into, okay, that code is law is one of these big terms you'll hear thrown around, that validates this stuff. But we're also relying on human nature. And this is where game theory comes in to say, look, if you do the rules correctly, you can screw it up, right? You can cheat, you can break things, as we'll get into a little bit later. But if you do, it's going to cost you. And hopefully, if we design our systems right, it'll cost you more than it's worth doing. So everyone plays by the rules. So that's what makes blockchain special. There's some definite caveats to this on private networks, especially private blockchain networks that we can get into. Some of this it doesn't always apply. So then what do we arrive at? This blockchain thing, the data structure plus this protocol that helps us make sure everything is correct on it. It is a distributed ledger, right? So ledger you can think of like in the banking definition, right? This is just a notebook where everybody's writing down what's going on. For instance, account balances. So this distributed ledger is immutable, meaning that it cannot change over time, right? That once it's set forth and out there in the world with some caveats, it cannot be revoked, cannot be erased, right? There's no single point of failure either, right? Because it's a distributed network. So many peers have a copy of this database, and many peers are willing to give you this information if you request it. It's not controlled or operated by any single entity. There is no Bitcoin central server or chief operator or anything like this. There is a peer set that all agree to these rules and protocols, and they just run with them, right? It's absolutely transparent. And I really want to lean into this. By transparent, I mean that everybody in the world can see this plain face, plain text, what's going on the network. So one thing that a lot of people come into blockchain with the idea of is that you can have privacy on a network intrinsically. There's pseudo anonymity, and we'll get into that more into the assignments where you'll learn a little bit more about the cryptography behind this stuff. But I would think it's generally should be implied all public networks, public blockchain networks are absolutely, everyone knows everything about everyone on it, anything that goes on there. So they're absolutely transparent. Big pro, big con, lots of things to it. The cool part, though, it's absolutely permissionless, meaning that this public blockchain, anybody can read from it, right? As we just were talking about, and anyone can write to it if they're willing to pay. At least that's some of the game theory around this, right? So as long as you're able to communicate to the network at all, you can read and write to it, which is pretty cool. So that's why people are hyped about it. That's why I'm hyped about blockchain, something new in the world. Once you confirm something on this ledger, it is absolutely final. It's an open database, right? Remember, there's no firewalls, there's no administrators, there's no admins, right? We can trust it absolutely without trusting anyone who's using it. That's a pretty big mind blower, right? Like, at least to me, that's a pretty big innovation. Totally changes the fundamentals of some of how we think about cybersecurity in very specific contexts. So then what does a blockchain look like? I think last week we assigned, if you missed it, a three brown, one blue video, which I don't know, man, and maybe you can throw that link up back in the chat for people if you missed it. He explains it so well about the Bitcoin protocol in particular. It's how does Bitcoin actually work? But basically he describes this, right? Is what does a blockchain look like? We've got a database that's got some header information, meaning that each one of these blocks has information about what's in the block, including one of the most important parts is the hash of this block, right? Which is a fingerprint, as you'll learn in today's assignments if you don't know what a hash is yet. It's a fingerprint that assigns this block a unique identifier, right? So that we know that if any teeny tiny little bit of this block has been changed, that the hash is totally changed, and we can't guess it, and basically at all with the cryptography using. So then, if we know we put in a block correctly on the network, and we have a hash for that block that we can verify is correct, then we move to the next block and the next block and the next block and put in that previous hash. And we know for sure that those fingerprints all line up out to all the way to the Genesis block, as it's called, the very, very beginning of all of this. So definitely lean into the videos and readings to learn more about these concepts and terms and how they work a little bit. Computer File does a great job explaining this. So then let's see if I can open this guy up. Ethereum Live. I'm going to copy this link address. I should have had this prepped beforehand. Tell me if you guys can see this. Like probably not. 1 second. How about now? No.
Yes, we were able to see it.
Awesome. So if you guys want to go check it out, this is Ethereum.live, excuse me. This is a real-time view of the Ethereum blockchain. So you guys have probably at least heard of the Ethereum blockchain at this point. And if you haven't, this is a great way to get an intuitive sense as to what it's doing, right? We're having all of these blocks, which you can go ahead and look at various blocks here on a block explorer. I won't get into this too deep, but you can actually see what the things that we're talking about, like the which block in the history is it, things, all the information, the metadata around it, as well as its overall hash, right? Which is defined here, is mined by this, and we can find all the information we need here. So, and then within it, you can even see things like individual transactions, right? I think so. We can see things coming in and being assembled right now on the Ethereum blockchain live, which could be transfers of different amounts of Ethereum or contract calls, which we can get a lot of as well. So, like, I won't get into this too deep. And a lot of these terms and concepts, those who are new to the blockchain space, I would encourage you to go and explore. And like when you don't understand something, like what the heck is an uncle block or something like this, go look it up, and I think you'll learn a lot. All right, let's make sure the slides are coming back up. Cool. So now we know kind of like high level what a blockchain looks like, and they time to learn more about the terminology. Go play around and understand a little bit more about what Ethereum does. And with that, I want to take a break for a moment and jump into questions if you guys have any. So I don't know if we have any from the chat that are worthwhile bringing up, man. Maybe we can bring some people up on stage.
Yeah, I think for now, I would love for you guys to ask questions, and we'll see when we get a great one.
Yeah. Hopefully, there's some definite questions linger in your mind, or something was confusing. And if not, we can keep going. Okay. So they said there's a chance of 1 on a whole big number, right, to crack the code. And they said that it's almost impossible. But I guess computers will do it in the future. So I guess it depends on what you mean. But can you crack hashes, for instance, or can you crack public and private keys? You'll find out more about that in the assignments this week. As it turns out, the chance is 1 in, not like 1 with 10 digits behind it. It's a whole lot more than that. At least in the cryptography that they use on Bitcoin and other networks. The chances that you'll break these with normal methods to go ahead brute forcing and trying to find basically the solution to unlock this stuff and crack the code is basically impossible. There's more things that you have to test than there are atoms in the universe, which is pretty crazy. So, good question, though. Real good question. Rock on. Okay, well, why don't I jump back into it then? Good question. We'll get some more good ones going in the chat while we're moving through. All right, so blockchain tech 101. Let's change gears a little bit. We know a little bit about what blockchains are on the back end. Now let's jump in, like, again, a little bit deeper. So once we confirm something on a blockchain is final, and we know that we can trust this database without trusting anyone using it, but why, right? Like, don't just trust me. We got to figure out why that happens, right? It's pretty important. If we don't understand why it works, then like it doesn't. We shouldn't trust and use it. And then there definitely caveats exist that once it's confirmed that it's final. There's different structures we can talk about and get a little bit deeper into. It's not always as simple as you might think. So what is a blockchain network then? Right? It's a set of peers that include nodes, full and light nodes, as we'll talk about a little bit more. We have validators or miners in the set of peers as well. Right. So what these nodes on this blockchain network provide are services for each other and for clients, right? These clients could include things like wallets or dApps, the things you're going to make in class, right? It's going to be fun. You can get a little bit of a sense of what this looks like here in this small image. I think we have a larger one a little bit later. But basically, like users on their phones might control public and private keys here. Specifically private keys they might have like on some device, and they're issuing transactions instructions for miner nodes, right, or validator nodes, depending on which kind of network we're talking about, to say, hey, I'd like you to send balance from Alice to Bob, please. I'm Alice. Here's a signature that proves I'm Alice. You'll find out more about all those terms in this assignment if you're not familiar with this. And then those blockchain nodes are going to go ahead and process these transactions and put them into blocks if they're valid, right? So what is a miner or validator, right? What is their role in the network? So this is a node that gathers these transactions as we were just discussing, right? It groups them into blocks, and then it's specifically looking for paid, right? Talking about those game theoretic incentives, right? These miners are paid to make this service happen, right? To generate a valid block, right? And then once it knows about these transactions are correct and these blocks are correct, it's going to have some protocol in which to let the other nodes know about that they found it, right? And then these typically store block data. All right, not always, but typically. And then they'll accept queries about blockchain data. So you can go out and ask your peers, be like, hey, at said block, did you see this transaction? Like, does that exist in your network? Right? Something along these lines. Most nodes, not all nodes, will reply to you with this information. So here, the one asterisk is optionally, generally not, right? So we don't necessarily have to have all these miners storing all of this, especially in the context of miners. They might not store all the blockchain data. But then we use this on cryptocurrency networks. There can be private networks that are feeless, for instance, where you don't need to pay for transactions to be validated. But we'll get into more of the technicals later on in designing these game theoretic systems as to why it's really important to have some mechanism to make it at least somewhat costly to submit a transaction to the blockchain here. So then what is a full or light node, right, as we're talking about? And specifically, this is talking about a client, right? This is a node that validates block data only, right? It can broadcast transactions and can gossip to its other peers in this network. It can store blockchain data, right? And it can accept queries about data, right? Because it might hold on to this. And a full node will have a full record of the blockchain, right? A light node typically has a pruned sense of the network. And what that means here is that one of these nodes out there in the universe is going to be able to relay some of the information all the way down to maybe just the most recent block. Maybe they only know about specific transactions that you care about. Maybe they only know the blocks that are associated with your account on the network, for instance, stuff like this. So it gives you a sense of who lives on the network. So then what is a client, right? So now we're done talking about nodes in the actual blockchain network, right? A client who talks to the network, right? These are ones that form and sign messages with those private keys that are embedded, for instance, in like a wallet software. This would be a client. It relies on communication with the node for data validation, typically, not always. There's new next-gen clients that are doing validation in the node itself, which is pretty cool, or the client, I should say, itself. It can broadcast transactions, basically instructing the network, please execute something for me. And then there really is almost, on most of these, almost no blockchain data. They're really reliant on some node, potentially one of these light nodes out there in the world, right? And a full client is then bundled, right? This is what I think most people would suggest you use if you don't trust the nodes that you're talking to. Just run your own, right? It's a light client that has an embedded node within it, right? And this could be a full node or a light node. So then here, kind of summing it all up, right? On the network itself is kind of pictured in this little cloud. We've got a whole bunch of miner or validator nodes, and these are all peers on the network. And outside, we have users who have access to keys and account information and submit transactions into this network. And that's what makes it valuable. Okay. So then how do we get to this consensus, right? Because so far I haven't been talking about how we actually make sure that the network is processing correctly. Because like, who knows? Maybe one of these miners is trying to fake us out, right? It's trying to do what's called a double spend, right? It says, okay, well, one user said they wanted to send money to somebody else. I'm going to go ahead and play that back from this user to try and send it to someone else before the network sees the rest of it. So you try and cheat and lie to the rest of the network and send money to two people at the same time, right? It's like, why can we stop that? Because we have a consensus mechanism that ensures that we all share the same version of the truth, right? So there are many, many ways to go about achieving this. And typically what people first encounter is Bitcoin's method. This is proof of work. So this is mining. I won't get into this too deep, but this is explained in that three blue, one brown video pretty well, I believe. Talks a little bit about the mining protocols. And I would call not necessarily next gen, but definitely evolved beyond proof of work. There's proof of stake networks. So, as opposed to like spending a whole bunch of energy to try and build a new block, you'll put a whole bunch of cryptocurrency on the line that says, if you can prove that I'm faking this out over some period of time, you can take those funds from me. You can slash my stake in some various forms. So this game theoretic mechanism comes back in, saying that if bad behavior is detected and we have very complicated mechanisms to figure this out, we're going to go ahead and take your money from you, right? Or kick you out of the network entirely, or both, right? And then there's Byzantine fault tolerance protocols, which are some of the predecessors to all of this and kind of underlying a lot of this stuff, pretty tightly coupled with proof of stake networks. The implementation details, if you're curious and you're interested in the deeper blockchain stuff, come talk to me. That's my day job. I talk a lot about how blockchains actually work. And there are many, many more protocols. Check out in the slides. There's a link to a few more that you can check out. And so, for instance, Avalanche is a novel new one that was not mentioned here. Lots of ways to go about trying to make sure that everyone has a chain version of the truth and no one's trying to cheat or lie. So then we're kind of alluding at it the whole time. What is cryptocurrency, right? We've just been talking about blockchain that might have like this weird way to value stuff and pay for things. Cryptocurrency, right, is a blockchain that stores financial transactions specifically in some capacity. It doesn't have to be its only function, but it's definitely one of the core functions. The cool part about what cryptocurrency is, at least public cryptocurrencies, is absolutely self-sovereign ownership. And so this little diagram here is pretty novel. In the assignment, you'll definitely have more exposure to what this actually means. But if you have this private key, which is a unique number basically in the universe, a piece of information that no one else could possibly guess, no one else could probably guess, even if they had the biggest computers in the world for infinite amount of time, basically, right? If you have this piece of information, you can prove to the network that you own this information without exposing that information, which is pretty cool. So this is public key cryptography. And they're on this network, right? This is a blockchain network. It's peer-to-peer. So the individual, the self-sovereign person who has this key, can talk out to anyone on the peered network. And if they're submitting a valid transaction and associating some payment, the chances that it'll get processed are very, very high. And you don't need some third-party intermediary to facilitate this thing. You just need to be able to communicate with the network. And because of that, it is uncensorable, meaning that really, unless you have a very onerous authoritative stance over the internet itself to be able to stop people from communicating with this network that exists out there somewhere, you can't stop people from communicating with it, which is pretty cool. So then once consensus is reached, the ledger is final, right? And what we arrive at then is an open database that we can trust. Again, if it's more costly to successfully cheat than it is to play by the rules of the network. So all that said, there's ways that you can get around, like in these consensus mechanisms. You might want to cheat, but you got to work real hard to cheat. In fact, it's probably going to cost you more in the work than it would in anything you could get paid in. Right? Same with proof of stake. There's more at risk if you get caught, and you're very likely to get caught, than there is to gain from it. So that's what makes these things novel. For that, I want to jump into some questions. Do we have any good ones, Brandon?
Yeah, so definitely think we got a couple. Yeah, so for one of the latest questions, so it's not possible to ban crypto.
I think it'd be very, very hard to ban crypto. And this can get socio-political very quick. So let's bring it to Slack and let's discuss it out. But it's I like to think of it as a hydra. Over the few years that I've been in the space, for instance, China has put in very soft to now very hard bans on using any kind of public cryptocurrency, especially Bitcoin. For instance, outlawing mining and stuff in the area. But I know for sure people still mine there covertly now, as opposed to overtly, very, very, very overtly, and people still use the network. So even if it is something that's illegal in particular jurisdiction, people can still find ways to get around it. Should they? I mean, that's up to the individual to decide.
Awesome, thanks. Another question Melissa asked was, what kind of calculations do miners do and how do they do it? if that's simple to answer.
So I think that we can get into that more in the assignment a little bit. But effectively what they're spinning is a hash with a nonce associated with it. So the protocol for Bitcoin in proof of work anyway is I've got a hash of this block, right, which is a unique fingerprint that we can't influence. We don't know what the outcome of this hashing algorithm is going to be. So what we can do is inject a little bit of randomness into this block, and it's called a nonce, right? In the context of the blockchain, in context of Bitcoin especially, right? So this random number we're spinning with all the rest of the information held constant. What that influences though is the end up that fingerprint, that hash. So we take the block contents and we spin that number, random guess and check basically to see if I put this number in, what's the hash? And the protocol says I will not accept the hash unless it is less than said some number, right? And I believe the Bitcoin white paper actually describes this really well. And this is in the class references on the website. You can go and check out the Bitcoin white paper. It's like 2 pages, and it describes this protocol much better than I just did. And that's effectively what you get in the end.
Awesome. Thanks, Dan. And one last question, which was great, which was if a group of fraudulent miners code all together, maybe they can beat the fraudulent, that process. And this was asked by Leia, if you want to clarify as well.
Sure. Yeah, Leia, maybe, if you want to clarify a little bit more, but I think what you're after is, can you collude with a whole bunch of the network and cheat the network? The answer is yes. And a lot of these have, this is the big caveat. If the majority of the network is trying to collude against a minority, they can take over the network, right? At least in most of these protocols, that's one of the key faults. In Bitcoin, this is called a 51% attack. And that 51% of the network, really it's 50% plus delta, just epsilon 1, just a teeny tiny bit more, probabilistically can take over the network. Doesn't mean they will always. It gets weird. The Bitcoin white paper actually describes this and talks about the numbers. And it's not super hard. The math is not super hard, but it describes the conditions in which you can take over the network. And in proof of stake networks, most of these are Byzantine fault tolerant. At least they use practical Byzantine fault tolerance along with an assumption. For instance, like on Polkadot, I'm familiar with 1/3 of the network is assumed to not be malicious. And there's different reasons why this lower barrier is actually okay, in the sense that we need 66% of the people to be doing the right thing, because we know everybody on the network. In proof of work, the cool part is that anybody can spin up a miner and they don't have to declare anything about who they are. And proof of stake, you have to set up an account with money, a substantial amount of money typically, and put that on the line. So you've identified yourself, and a lot of the times you even have to identify the computer that you're using to do this, at least out to the network. It's a static computer, so they might even be able to like geotag you and stuff. So that visibility and transparency, much more into who's operating on the network, also puts a little bit more skin in the game than just your stake. It's kind of cool. Rock on. Well, let me jump back into the slides then, and then we'll have more questions here soon. Cool. Or wait, so are many, but if a fraudulent loop comes together, maybe it can be, oh yeah, so this is a good question, yeah. So let's talk about it more in Slack too, and maybe afterwards we'll keep going for now. So now we know a little bit about blockchains, and we know a little bit about what cryptocurrencies are, right? So let's go to the next phase of evolution in this, is smart contracts and dApps, right? So what else can blockchains do, right? Blockchains can store anything. Typically, we're talking about financial transactions, the cryptocurrencies, but they can also store identities, credentials, maybe their deeds, rights, permits, news articles, blogs. Maybe you want to store the entire Library of Congress on a blockchain. I don't know why. But what if you stored code, right? And not only just the code, right, but a uniform way for everyone on this peered network to run the same set of instructions. So it's the code as well as the engine to run that code, right? This is what a smart contract is, right? It's pre-programmed terms and conditions code, right, that may include storage and transfer of a cryptocurrency asset, for instance, right? And it lives on a decentralized network. It runs and validates these programs. So it actually is executing the programs in this smart contract code and validates them across the network, and uses these consensus mechanisms that we just talked about, so that we can guarantee that everyone's playing by the right rules, right? It's immutable and transparent, just like any blockchain is. And the terms are absolutely final on issuance once they're actually settled on the blockchain, right? So one of the terms I like to use is unstoppable code. There's a great video you'll watch by Andreas Antonopoulos as part of the assignments, not necessarily this week. I'm sure it's coming up though, where we talk about the power of unstoppable code for good and for ill, as we were talking about earlier, whether it's legal or not. He gets into that pretty well. So then what is a token, right? So typically when people are talking about this, there's some, talking about lingo that's not always decided on. Typically, this is a unit of account that's intrinsic to a smart contract. So people might have heard, who are familiar with the industry, of ERC20 and ERC721s, as we'll talk about in a moment. These are the fungible and non-fungible tokens standards, the most common ones on Ethereum, right? So these are contracts which define a new unit, right? A token that operates on the network. So they can define like the balance of this token and who owns the token and things like this, and ways to interact with it, for instance. So these are typically used to interact with a contract or dApp. So most people who are designing a dApp typically lean into having some kind of token. Doesn't mean you need one. Absolutely not. You do not need one. Most people are incorporating these because that's one of the novel things we can take advantage of, is being able to manage money, because just managing anything in a smart contract doesn't always make sense. Managing money, especially that's intrinsic to the chain, makes a lot of sense. This might grant access to features, might gain you rights, and many more things. You dream it, and people are thinking about it right now. They may be exchanged with each other. So typically, right, these represent some kind of notional value. There's a lot of open markets. I got some slides here to kind of pop some eyeballs if you haven't already looked at some of the cryptocurrency markets, right? So they might have some notional value with them, but they might not. So for instance, if one of these tokens represents like your identity in some way, maybe this doesn't have some financial direct way. You can't go trade them on a market, at least maybe I shouldn't if it exists. So, but this is now all typically in a dApp context, right? Other definitions definitely exist for the token, but that's the one we'll use as a working one for this class. So then we talked about it before, and you guys have probably heard this term before as well, is NFTs. What is that? It's non-fungible tokens, right? So what's a fungible token? A fungible one is not a non-fungible one, right? These are like the ERC20s of the world. Fungible meaning that you can interchange them and they're the same. Like if I take $1 out of my pocket and I give it to you, and you take a different dollar out of your pocket and you give it to me, we're even, right? I don't care which dollar I have. I just care how many I have, right? So that makes it fungible in that sense, right? Non-fungible tokens, on the other hand, it very much matters which token you have. And so, for instance, if I take a cat out of my bag and give it to your cat, and you take a different cat out of your bag and give it to me, we're probably not even, right? Like, I like my cat. Don't take my cat, man. So they're very different, right? That's the notional difference here. But so understanding some of this token hype, right? I believe here we can go ahead and look at this. Are you guys seeing this video now? Right. Looking at some money that's being put into these tokens, right, over time. So in the 2016 range, we had, tens of millions of dollars in this, mostly Ethereum at the time. And as we're moving into 2016 and 17, all of a sudden these numbers start jumping up and up and up and up, right? Like these things are going pretty nuts at this point. And then all of a sudden 2017 starts hitting, and these really start ramping up and up and up, right? So this is about the time I was entering the space, was somewhere in this 2017 2018 range, and all these projects all were starting to sell and make so much money, right, at the time. And this is just a picture that goes out to late 2018, right? And since then it's been exponential still. So money is flooding into the space, mostly around these tokens we just talked about, mostly fungible ones, right? Like you might have heard about Telegram did a raise and then had to drop it at one point, right? Because of some lawsuits. The petrodollar like came out with some crazy stuff. Polkadot, this is the company that we get to work with as a sponsor, right? Raised a whole bunch of money. And this was at the time too. And I think since then, a lot of these assets are appreciated on the free market. So it gives you a sense why people are so darn hyped up about this thing, right? Because there's a lot of money in this space, and rightly so. At least I think so, in a lot of ways. And then NFT hype. I don't know if you guys have ever heard of the recent. I think it was $46 million. One that this piece sold for. This is by Beeple. It's a collage of all of his different works. If you zoom in, it gets pretty weird. He has some fun art that he does, but he sells all these as NFTs. This one was at Christie's auction house, which is one of the most renowned art auction houses in the world, and sold for I think, if not the top five, it was pretty close to the top, maybe the single largest spend on a single artwork for someone who's a living artist, which is crazy, right? So this is why there's hype around this too. And so really then a lot of people are like, hey, I need some money, right? So I should use a blockchain, right? No, please don't do that. Right? Like this is really an assignment that we're going to be doing a little bit later to help you go through some flow charts, right? That will not look like this one, be a little bit more drawn out. And it'll encourage you, especially as entrepreneurs, to really introspect why you're using blockchain. Because in this class, we're not going to use blockchain because we have to, because it's in the course title. We're going to use it because we should. So at least at some fundamental level, we should have a good reason for that. So preview, that's going to come up in the class here pretty shortly. So then all that said, right, we're here to build dApps. What is a dApp, right? I don't know. Oh, I get it. It's a decentralized application, right? Meaning that it's living on one of these decentralized distributed networks that we talked about. Typically, it interacts with one or more blockchain networks, right? And as we're evolving in this year, especially, we're going to have them probably interoperate. Either interoperable is a big term this year between different blockchains. So you can have many blockchains to interact with. It's generally user facing, right? So you guys are probably building products that are not all this blockchain technology that I dig my brains into most days. It's the stuff on the front end. So building things that like our wallet apps, these clients that do something fun and manage stuff for an end user, as opposed to actually building out protocols and developer tooling like I do. Right. So these are then using contracts and currencies. So on your team, you're probably going to split up some of the load of working with either Polkadot, Algorand, or Ethereum in the backend to design contracts to build on top of one of these platforms, or using a currency there of your own, or maybe one that exists on their network. Right. There are many, many examples at the State of the dApps and the website you'll see here in the slides. And I guess I can share this as well in the course chat. So many, many applicable markets for these, right? And this is a really old picture at this point of the EOS blockchain of all things, right? But it gives you a sense of what is here that exists in as like categories generally. General data management and validation platforms, social and all kinds of content platforms have started coming up, exchanges, general markets for various products, crypto or not, identity and having security of some data on chain, right, or information on chain, payments, all kinds of payment processors, marketing, NFTs, right, games, all kinds of things, and all kinds of things even more, right? And this is an old picture at this point. There are so many things coming to the space, many examples. A lot of the things I hear you guys talking about in the Slack right now, I are reminiscent of what people have already been working on potentially. And that shouldn't dissuade you at all, right? I think that competition at least is a little bit of a good thing here. And we're so early in the game. Even if one of these projects exist, even if they're doing pretty well, it doesn't mean that you couldn't come in and just blow them out of the water. It takes very little here to have shifts in the dynamics of power because everyone's a startup. So go and check it out and understand that like this wild world of Web3, we're just barely beginning, and you get to help make it real. Like all the things that people aspire to, and I've been talking about with people for years. Like I'm excited to be part of this class with you guys because I get to see what you want to bring to the Web3 world, and I know we're going to make great things together. So with that, let's drop off into questions in the chat, and then we'll jump right into the class lounge.
All right. So I think James had a really great question that I'd like to invite him on the stage to ask.
Yes, please.
So we can go ahead and do that.
What are some examples of penalty for cheaters, and who catches them, and what's the process like? So typically, how this is done on the context of validation, right? So miners or having people who are proof of stake validators, right? These guys are going to try and submit transactions that are invalid in some way, or try and cheat by saying this is a valid transaction that goes to one side of the network, and I'm going to try my other peers on the network with a different transaction that's also valid, right? But what it does is if everyone agreed on this, I would have spent that same money, for instance, right, across to 2 different individuals. Maybe paid myself and double my money, right? So this is one way in which you can cheat. The penalty for cheaters, right, in the sense of proof of stake networks can be slashing. So you've got a big amount of money that you're putting on the line to have the ability to produce blocks on the network that are considered valid because that stake is there, right? If it didn't exist, you wouldn't be able to validate. You're just barred from the network, right? Proof of work, it's a little bit more complicated. You just have to have enough proof of work, right? So you do enough work to let the rest of the network know that that's valid. One example of a 51% attack that's been successful is interesting. You can look at Ethereum Classic. And if you look up Ethereum Classic block reorganization or reorg, you'll find many examples of this happening in the past few years, which are unfortunate. You'll have proof of work, some big mining pool comes up and they'll rent out hashing power. So the ability to do this proof of work. They'll come in and take over the network, having more than 51% of the network for some period of time to produce basically a different version of history for maybe hours or even days in some of these cases here, where they're able to inject and double spend money. So what do they get out of this, right? They get to send some money. Typically, these attacks are at exchanges. So they'll have a whole bunch of cryptocurrency they send to an exchange, trade it, and liquidate it, pull it out somewhere else, and then rewrite the blockchain to take their money back, right? So they're able to do this because they're able to spend a huge amount of work to convince the network based on the protocol that that's the new version of history is correct, because effectively the rules of the protocol are the most proof of work is the canonical chain. It's the truth, right? So it gets deep
Gotcha.
quick. Yeah.
Yeah, thanks, Dan, for that explanation. So I was wondering in terms of that process, then so where does that execution of so assuming that you're able to use the mechanism to catch the cheaters, and
Mhm.
I'm assuming you run some kind of process to by either doing slashing or doing some other kind of stuff. Essentially, you're modifying some kind of identity for that contributor or validator. Is that the case? Who runs that process? Like, how does that work?
So let me see if I got that right. So it's basically, how would you try and change your identity as a staker?
Oh
And
no, sorry. So when you actually catches the cheater, when you
Mhm,
try to apply the penalty,
mhm.
who applies the penalty? Is that also in a like I guess because the whole thing is decentralized, right? So
Yeah,
which user applies the penalty, or how's that penalty
yeah.
executed?
So that's depending on which network you're talking about, it varies. But typically, the protocol is that part of the protocol says if anyone in the network can valid or prove that this is somehow cheating, right? And there's protocols behind the scenes that you can do this, then you submit this either, like for instance, I believe on layer 2 networks, we'll talk some about, like zero knowledge optimistic rollups is one of these cool technologies. Somebody can say, hey, somebody cheated on this optimistic rollup, and prove to the network by submitting a transaction that it was invalid. And the network validators, right, on the Ethereum blockchain, they're going to take that transaction and see that it is correct, right? They can prove this mathematically. And then the slash is taken out of basically somebody who's in charge of making sure that that rollup is correct. Does that kind of make
Right.
sense?
So where does the slashing, like who applies the slashing? I guess that's what I was
Any
trying to
other
understand.
validator, right?
Okay, but they also do it through some kind of consensus, or
Yeah, so it's basically embedded in the consensus here. You can think of is that part of
I
the
see.
protocol is that if offensible behavior is taking place on proof of stake, then that user's account balance, which is locked up that they cannot remove it over some time period, that will be deducted some X amount based on the offense, or
I
potentially
see.
all of
And
it.
essentially, once you slash that, you add this information onto the block, and
Mhm.
I guess the value that's slashed, that they just evaporate, or like does that go somewhere else?
It really depends. So
I see.
it's entirely based on the network. And like my day
Sounds good.
job, I work on substrate stuff, and you get to choose your own adventure. We've got basically plug and play modules for you able to choose this stuff. So if you want to design a blockchain, and it sounds like you might, James, then you might be interested in substrate. If you're interested in plugging into one that already exists and understanding that, I think that Algorand or one of the Polkadot blockchains, parachains, that we'll learn more about here shortly, or Ethereum might be a good place. And you just plug into a smart contract.
Sounds good. Okay. Thanks so much, Dan.
Yeah.
All right. And Dan, I think there's one more really great question, which I'd like to invite Delon to come to the stage.
Cool.
Sorry if I'm pronouncing your name wrong, but just sent an invitation.
Oh, that's fine. It's Dylan, but thank you.
Hey, Dylan.
Hey, so yeah, Dan, kind of along the lines of what you were saying, where you could have a very powerful group of miners join together for a 51% attack. What are your thoughts on venture capitalists, not necessarily a 51% attack, but investing so much in these networks and owning such a big chunk,
Yeah.
and technically centralizing the network and centralizing decision power?
Yeah,
Whether
absolutely.
it be DAOs or proof of stake.
Yeah,
What are your thoughts on that?
absolutely. I think it's an existential threat, and it plays itself out pretty commonly. I'm a big fan of this book. I don't know if you guys have ever heard of Radical Markets. You heard of this?
No.
I can share it more in the Slack. I'm a fan of this. Is the Economist Book of the Year in 2017, I think, or maybe it's 2018. This guy Glenn Wild, his proposition in this book is one of the title chapters. It says capitalism is monopoly, right? And basically, all these capitalistic systems that we're designing, these game theoretic incentives around, they typically devolve into monopoly by their very nature. What this book
Right.
proposes, though, is some mechanisms to try and actually break that up. Right. So we can still have free markets and we can still have market like incentive mechanisms, but maybe we just need to redesign the machine. Right. Maybe we need to redesign the protocol somewhat. So I would say that absolutely
Anti-whale measure or something like that? Something along those lines?
Yeah.
Okay.
And there's various mechanisms to try and go against this. For instance, I do my work typically around the Polkadot protocol.
Mhm.
And we have nominated proof of stake is what that it revolves around. So it's a proof of stake network, but people will nominate. So individuals who have some smaller amount of funds will basically say, I trust a set, not just an individual, a set of somewhere between, I think the typical is like 10 to 20 different validators on the network. And we have a protocol that automatically behind the scenes will delegate to make it the most distributed as possible. Right. So it's not your job to try and decentralize as a user of a nominator on Polkadot. It's your job to select a set, and the protocol actually will go through it and try and make it as even and equitable as possible. So it's not foolproof, absolutely not, but it helps diffuse some of that monopoly at least a little bit.
Okay, thank you.
Yeah, for sure. But you're right; it's a really hard problem, and I don't know if I'm convinced that it's solved. I don't think it is yet.
All right, thanks. So I think with that,
I know we're looking at the time.
I don't see any other great questions there.
So you guys, I am definitely hyped up to talk to you more about this and jump into the lounge. But I know that we're coming towards the end of class time. Is that right, Manon?
We're at 7:30, so we still got some time.
Oh, we do. Great. Then, yeah, why don't we jump into the lounge? And at least for as long as you guys will let me, I'll talk to anybody here locally with any questions you have more. And know that we're kind of confined to smaller groups, so I can pop around tables. But I trust that some of those people who can explain blockchain to like the expert, level, please go and find yourself in a little corner and let people know in this global chat which one you're at, so that people can ask you more questions. Cool.
Cool. And just another reminder to fill out the attendance form and also focus on team formation as well.
Yes. So teams are important. I think that Manon, you sent out an Eventbrite link, right? So we're going to have class on the 1st next week. That's the next Tuesday. And I think I'm going to fly out and be there with you in person. Typically, I'm out here looking at snow in Colorado, but get to come hang out with you where I don't think there's snow. Is there snow? No,
there's no snow here.
Damn.
Berkeley.
But you're absolutely right. It'll be a good time to meet and form your teams finally. I believe that our hard deadline for forming teams is going to be the end of next week. So this is a great chance to go and really figure this out in person. And then the other announcements, right? I think we should list off. One person I think I saw in the chat was talking about Ethereum Denver. Awesome. Like this, I've been a big fan. I happen to live in Denver. I'm one of the stewards of ETH Denver, and I really hope that all of you go and apply actually right now. ethdenver.com/apply. If you'll take the time either right now in class or just after, we're going to actually have a choose your own adventure for the class on the 15th. I believe the 15th and 17th, where you'll pick any one of the literally 200 plus live stream sessions that are going on, and we'll have you do a reflection on what you learned. So go and like dabble in virtual land with I guess the kind of metaverse thing that we're going on for ETH Denver this year. You're going to learn a lot. This is definitely where I learned all the things that I know, and basically what got me into the space was Ethereum Denver. I was a volunteer at the original and been a steward since. So ETH Denver is going to be a really good place to learn and to grow your professional network and potentially find out about a lot of ideas. Like you're going to find basically what's bleeding edge. A lot of announcements get made there that it's the first time anyone's heard about a particular platform or product or method. A lot of people talk about great stuff in the industry. So apply, go and find the schedule. It's ethdenver.com/schedule. This is being assembled. .com/schedule.com. That's it. You can find what's already published for Biddle Week stuff that's going on, which we're going to have that content is like choose your own adventure, and then the main events and big prizes are happening. So with that in mind, also you can compete in this if you'd like to as a team, or individually. It's a big hackathon. There's big prizes. There's something like $1 million, I think, total prizes, plus another like I think 2 million in convertible grants or something like this. So it's fun. Don't miss it. It's all virtual too. So it'll be a great time to learn and grow. And then I'm trying to see, I think we had a few more things that we wanted to discuss before we jump out.
I think, Dan, it might also be nice to just flash the website, the course website on
Yes,
screen.
indeed.
So, upcoming assignments or assigned materials.
Perfect. Because I don't think we've formally shown off any of the websites just yet. So you guys should be able to see my screen, I think. Yes.
Yes.
So ETH Denver, go apply. It's going to be a lot of stuff. But we also have a website that's hosted on GitHub if you guys want to check it out. The hosted version is here on the side. So specifically, and I'll drop this in chat for y'all, this is the course website. So we've got, if you haven't already found it, which I hope you have because there's some assignments in there, a little bit about the course and who's here, right? But most importantly, what you guys will be referencing is the schedule, right? So this is being filled up over time, but it gives you a sense of what the assigned materials are this week. So let me zoom in a little bit for y'all. Right. We just did the introduction to Web3. You can find my slides here. We want you to watch all the cryptography videos. So these are now listed under the cryptography section in the resources part of this website. And they're all short. I think these are like 5 minutes or so each. So, we're talking like 20 minutes maybe. You can learn about like hashing. We talked about public key cryptography, signatures, and secret sharing, right? So this is really kind of fundamental to how all this stuff works. And Computer File is amazing. So you should definitely check. I hope you'll like it. I like these guys a lot. Although I'm kind of nerdy, so what can I say? And then there's a great recent article here by Moxie. This is the guy who wrote signal.org. This is that private messenger you might have heard about. So he's kind of famous in the industry, and he has a kind of critical critique on this whole thing we just talked about, Web3 and like NFTs. Yeah, I really encourage you to go and take some time and think about this and have some reactions to it. So this is definitely something I'd love to see some reflections on, whether it's in Slack or over Flipgrid or whatever it might be. I don't think that we need to formally assign you other than just reading this, but I would love to encourage and get some feedback on what you think about it. And then finally, the last little bit here is that we got a quiz for you. So this is just to kind of get a sense of, did you ingest some of this information we just went over? So like definitely my slides are here, and there's extra resources that are on our webpage, right? But go through and just do your best at this. In the end, you're not going to be graded on how correct you are or not. You can retake this as many times as you want, right? It's just basically we want to see if you put in some effort. And then in the end, we're going to ask you to go ahead and give us some feedback is the last stage there, and make this quiz better. So that's a little bit about what we're looking for this week. And then absolutely the last bit, right, is sign up for this Eventbrite. Yeah, because we're going to see you next Tuesday. I think I'll be there in person. I'm getting my flights probably tomorrow. Make sure that I can see you. And this is at the this particular location here, right? Which I get to find out. Maybe my Uber driver will find out to come and visit y'all. So cool.
Yep.
I think that was probably all we wanted to share. Then maybe we'll jump into the lounge. I think
Yep,
we
I
should.
think we're all good. And yeah, should definitely jump in.
Cool, guys. Well, I'll see you in the lounge. We'll do some more team formation and more Q&A. Thank you all.